Okay, so we're back for me to demonstrate another example to you. And in this example, I'm also going to include an additional piece of information, and that's going to be to talk about what we mean by the lattice rectum, which is a line segment which passes through the focus and has endpoints on the conic section. So I will draw that in at the end of this problem so we have an idea of what it is that looks like. But we'll start again from x squared minus 2x plus 8y plus 9 equals 0. And we should immediately think that this is going to be a parabola that has a vertical axis. We're not quite sure yet whether or not that's going to open up or down, but we'll find out in a moment once we do the problem. So I need to complete the square, so I get x squared minus 2x. I'm going to need a 4 plus 8y plus 5 equals 0. Oh, I don't particularly care for those numbers, but it will be all right. So we get x minus 2 squared equals minus 8y minus 5. And ultimately, I'm going to get x minus 2 squared equals minus 8 outside of y plus 5 over 8. So not necessarily the simplicity of the numbers for our first problem, but we can still move along with them. We should, before we do anything else, figure out what p is. So 4p is going to be minus 8, so p equals minus 2. And we'll get to in a second what that p means. The vertex is going to be 2 minus 5/8. So I'll put that in. 2 minus 5/8. It's about here. The focus, because we have a vertical axis, must move above and below. So this time the focus is going to be 2, and then because p is minus 2, that means we have to go down 2 units. This is the parabola which is going to open downward. So I'm going to have minus 21 over 8. No mixed numbers, please. So go down 1, 2. So that's the focus at 2 minus 21 over 8. Which means the directrix must go up 2. So it's going to be of the equation y equals, let's see, 11 over 8. And that's going to be here. This is y equals 11 over 8. And the last thing that would be useful for us to do before we go about graphing it is to figure out what intercepts, if any, this graph will have. And we can tell by the fact that the vertex, which occurs here at 2, minus 5/8, and we can tell by the fact that the vertex is there that we're not going to have x-intercepts because we're opening downward, but we will have y-intercepts. Particularly, I'm going to move over here, you can look at the y-intercepts for a second. The y-intercept is going to be, we'll have 8y plus 9, so y equals minus 9/8. Notice the way that's going to help us figure out, okay, that's going to help us figure out the, basically the shape of the parabola, right? And that those x-intercepts confirm for us that this is a parabola that actually starts to stretch out much quicker. This is a much flatter parabola, and we'll talk about the eccentricity eventually of this parabola, than the previous problem. Alright, so that's the same set of information that we included in the other problem, and now I want to talk about the lattice rectum, which I'm going to go and draw in. I'm going to remove this labeling of the focus just so we can have nothing get in the way of where the lattice rectum would be. And the lattice rectum is the line segment that I'm drawing in right now. Okay, this is the lattice rectum. What we know about it is that it goes through the focus, which is here, and it attaches to the endpoints. And we can find various things about it. For example, we could find the endpoints, we can find the length, etc., etc. What we know, okay, the only thing we really know about the lattice rectum is the y coordinates of its endpoints. Right? We know that the y coordinates of the endpoints are minus 21 over 8. Now, of course, I've chosen a somewhat nasty problem to figure this out. But if I want to figure out what those x coordinates are, I'm going to go back to the original equation, x squared minus 2x plus 8y plus 9. And I'm going to plug in that minus 21 over 8 for y. X squared minus 2x plus 8 times minus 21 over 8 plus 9 equals 0. And we'll continue through. And we want to find what those x coordinates are. So we'll go x squared minus 2x plus minus, looks like minus 12. And this doesn't seem to factor very easily, at least not offhand, so we'll go into the quadratic formula, x equals 2 plus or minus, and you can follow along as I go. It's 4 plus 48 all over 2, so x equals 2 plus or minus the square root of root 52 all over 2. And those are where the x coordinates come from. And notice that this distance here, okay, we're trying to figure out how far away we are on each side. Okay. So we really want to know what the distance is between the two of them. So we have an endpoint that's 2 plus root 52 over 2, and an endpoint that's 2 minus root 52 over 2. Those, of course, would be in the other direction, like so. And if I want to know the length, I'm just interested in the differences between them. So I'll subtract, and I should get something that's root 52. Essentially, it looks like it's going to be just root 52. Right? That the length is going to be the square root of 52. And there's various reasons why this would be interesting. It's a specific characteristic of the parabola that would allow us to go on and find the equation afterwards if we so desired to. For now, I would say that if you do these problems, you should practice finding the endpoints of the lattice rectum and just recognizing where it is. Once you do it once or twice, as long as you know the definition, it's not hard, it's not really any different than any other portion of the problem, but you should be familiar with that characteristic should it show up in other places. Alright, so that should be enough information to do the problems for the homework tonight. And I'll obviously put a couple of solutions up for some of the problems. And if you have questions, make sure that you post those questions on the homework document so that I can help answer them before class.